Hi guys, welcome back to the Libris Custom Knives channel. Today we'll be talking about, today is the second part of our building a heat treatment oven series, and we'll be talking about the brickwork, and if we have time we'll be talking about the framework as well in a bit more detail than what we did in the first video. So the first thing you have to do, and let me just show you that, is your bricks have arrived if you bought them online like I did. Okay, and here they are. The first thing, of course, you need to do is you need to inspect them, both for damage, for example, over there. Okay, but I caused that, so I'm not going to hold any grudges against the seller for it. And another thing you need to look at is if they are the correct thing you've ordered, because that happened to me twice now, that the seller sent the wrong bricks. For example, you can probably see there over there it says TDM 23. So that's the good. 23 is the number you're looking for. The first time I bought it, the seller sent me grade 26 bricks by mistake. I had to return these. And even this time, even though I bought from a different seller, they still sent me one grade 26 brick for some reason. But because I won't be needing this brick anyway, I'm not holding any grudges against the seller. So after you inspect them and adore them and everything else, you will need to start arranging them and actually deciding on how you want your kiln to look. So first, let me put you in the cradle, and now we will actually be looking at how to start arranging them. Of course, once you first receive them, they are perfectly rectangular. They don't have any notches or slots cut into them. We'll be talking about that a bit later. So, of course, the first thing you're gonna do, and this may seem like a little dummy tutorial, but you want to be building your floor, and this is where you decide how long your kiln's gonna be. This is very important. For example, I know by now, because I pretty much decided on everything, that my kiln is gonna be 4 bricks long. So if I can find my tape measure, we can see that it's going to be, I hope you can see, let's do it that way, I think it's a bit clearer. It's going to be a maximum of 45 centimeters long. In reality, as it will turn out, it's actually going to be a little shorter than that. But this is where you need to be deciding whether you need to add extra bricks or whether you need to actually be removing them. For me, 45 centimeters is just perfect. I don't need it any longer than that, so we're going to be going with it. Okay, another thing you do is, rather obviously, you start building the walls. And this is where I'll be running into problems, because I don't have enough solid bricks left to actually show you. Because all the rest of them for me are notched, so I'll be wanted to talk to you about that. Okay, so turn your imagination on, and imagine that you have a second wall like that as well. The spacing between those two walls, it will, determine the width of the opening. And of course, whether you want it to be single high or double high will determine the height. If you are doing a lot of curved blades, for example sabers and various daggers and whatnot, which are curved, you need to make sure that your oven can accommodate that. So it needs to be higher or wider, probably higher actually, if you need to be putting a curved blade inside of it, so it doesn't touch the top of the oven, or you don't have to slant it and potentially short circuit any heating elements inside. But at the moment we'll be, because I don't really tend to do many curved blades at all. We'll be going by this. And of course you put your second wall down, and you put the roof, which is going to be almost exactly the same as the floor, and you have your basic shape. At this point, make sure you have enough bricks left to cover up the back and to do the front. Now in my case, the back will be made out of 3 bricks, and the door will be made out of 4. Okay, the reason I'm making the door out of 4 is because I want it to be quite solid, because that's where the opening is going to be. Okay, so after you've done this, here comes an optional step. You don't have to do it, but your kiln is, or the oven is going to be better if you do. And that is to notch pretty much all the bricks. What that means is, if I take these away, I will show you. And let's put them somewhere over there, for example, out of the way. Okay. And these are the actual pieces of my walls. And what you'll be able to see is that they are notched. They don't join with a single line coming through them like these ones did. Okay? The advantage to that is because now the heat does not have a straight path across which to escape. It actually has to, the heat can escape to pretty much the middle of the brick, but then it hits more resistance, and that will help you to keep more heat into your oven. At least that's the theory. Also, not only are these bricks notched on their shorter faces, they are notched along their long faces as well, so they match like that. This is important because remember, this is where your heating elements are going to go, so that's where all the heat is going to be concentrated. So this is another reason why it's important to put the side walls on their wider side rather than this, because you're putting heating elements in here, and as such you'll be milling or routing a small groove inside, so you're going to be shortening the distance anyway. A lot of the heat is going to escape from this wall if you just put it on this short side like this, so you want to have as much material as possible between it and the outside world, otherwise it's not going to be very effective at all. So there we go. The way you notch the bricks is, well, probably rather simple. What you're going to be using is one of these, which is an adjustable square. You can use an engineer's square or a tri-square as well. It's going to work just perfectly fine. A pencil, which funnily enough I can't find at the moment, but never mind. And you'll be using the tenon saw, like the one I showed you in the last video, which is that one over there. You can use any other sort of a saw to cut it. You can use a metal hacksaw, no problem. Lots of people have used it before. I personally chose a tenon saw because it cuts a very narrow curve, so it's a very narrow blade. At the same time, this has a strengthening on the back, so it doesn't flex as such. It does cut in a straight line. Okay, that's what you need. Another thing to know, and for this one I'll be pulling you out of the cradle so I can show you what I mean. Let me show you. Okay, if you have put your bricks together and you find that they don't match quite good enough, what you can do is, of course, and that's going to be a bit difficult to me because I only got one hand free, you can rub the bricks together. Okay, they are very soft and very, very abrasive, not only to cutting tools but to one another as well, and you can do that until the both bricks aligned pretty much perfectly, and that's gonna make sure that you lose as little heat as possible. Okay, obviously that's not gonna help you fix any bumped corners that you did by dropping your bricks, but never mind. Okay, so once you've done that, and you've done your other wall as well, which is this. There we go. There we go. All the bricks are notched properly. Then comes the time to do the roof. And the places where the heat is going to escape the most will be through the wall, through the side walls, and through the roof, because we all know hot air rises and it tries to escape through here the most. That's why this is usually the hottest part of the oven. Also because you are probably going to be doing the roof with bricks going on their shorter side, on their wider side, as opposed to this. Let me just make sure you see actually the camera shot. You could arrange them like that if you've got enough bricks, but that's going to, let's just have a look. Same 4 bricks, so need another 2. to cover the whole roof like that, and ideally you still want to notch them, so you're going to lose even more length. Oh yes, I forgot to mention actually, the disadvantage to be notching the actual bricks is that you lose length by doing it. You lose the internal dimensions. They become smaller, a lot smaller sometimes. For example, let me just have a look. Just for the walls, I have lost how much? Where is the division? Okay, this would have been the original length, which is just over 45, which is normal, because that was supposed to be, and now it is 44. I lost about 1.7 centimeters of material, which is not critical, I suppose, but you know, it would have been still nice to have it, because sooner or later there's going to come a project when I need the full length of the image. Okay, by the way, I didn't bother notching the floor. Not a lot of heat is going to be escaping through it, at least I hope it won't. And it's going to be elevated from the workbench by feet of the actual frame. So I'm not really concerned about that. Another thing you've noticed, if you've done any brickwork in your life, is we're not using any mortar, and that's for a reason. No matter how good the mortar you are using is, it's almost always is less it's worse of an insulator than these bricks. Okay, because these bricks are specially made, firing silica at very high temperatures until little pockets burn out, and then it becomes a very good insulator. You can't do that with mortar, and it's not going to be a very good insulator. So effectively, if you are just building your brick as you would build effectively a house from bricks, not notching them or anything, just putting mortar inside, you can't put them very close together, can you? Because there's no place for mortar to go. You have to leave a bit of a gap, and that gap is effectively become like a heat loss bridge, because this is where a very hot side on one side and a very cold, comparably, side on the other side has got a bridge across which to escape. The heat has got a bridge to escape, and it's got a gap, effectively, even though it's filled in. It's not filled in to par, effectively. So it is actually better, and I'm not the only one who thinks that way. I've read about this opinion on several occasions. It is better not to use any mortar whatsoever and just do everything dry. Okay, and another thing you have to be concerning yourself with is thermal mass, and you want the thermal mass to be ideally as low as possible. Thermal mass is effectively the mass of the weight of your oven, because that's what you have to be heating up in order to bring it to temperature. So the lower it is, the quicker you can do it. I've just put some support on the sides over there so my bricks don't tip over. So here comes the roof, and the roof, of course, is also notched for the size. Now, what you'll find is that these roof bits are notched in the same way as the wall bits as well, which means that they are notched not only this way, okay, there we go, they also notched this way. It has a lip, so the two roof tiles, they interlace with one another as well, so the heat has got a bit more trouble trying to escape. Okay, I really hope that's going to work, because if it doesn't, I'm going to look like a complete idiot. So let's put everything together. Okay, now for the top bit, for the roof, we use exactly the same amount of bricks as we did for the bottom. Okay, 4. But because we've notched them, we've lost quite a bit of length. And that quite a bit will become obvious when we look into there. Okay, all of this gap over here is a problem, effectively, because we need to cut another brick to go into it. Now, had I notched the bottom bricks, the floor tiles, I wouldn't have had this problem. But then, the length of my kiln, sorry to move you around, I just wanted to find my tape measure. then the length of my kiln would have been the maximum of 40, really, centimeters long, which is, well, that's a wee bit short, I think. So, what I did is I've cut another smallish brick from one of the offcuts I had, and it slots right in there. Okay, now it is lower down than the rest of them, but because that space is going to be filled up with vermiculite, I showed you in the previous video, I'm not too concerned about that. Okay, that should be perfectly fine. Now the tricky bit comes, and I'll put you back in this tripod. Now the tricky bit comes once you need to do the back. Okay. So basically, this middle brick was nice and easy. Just 2 cuts in the middle. Okay, and as such, it slots right in there like that. And of course, I need something to hold it in there. Otherwise, it's gonna want to fall out. There we go. Okay. The 2 side bricks were a bit of a problem, because this smaller brick that I had, it extends out by a little bit, so I can almost put my whole finger in there. Again, that's notching, if you like, okay? It's we make sure that there's no straight path for heat to escape. So, you take these other bricks, and these have to have a blind groove cut into them. The reason why it has a blind groove is because of this. It has to negotiate this corner somehow. So what it does is it engages like such. Okay? That's why you need this stopped notch or the stopped cutout in there to make sure that everything lines up perfectly. And of course, mirror image, rinse and repeat on the other side. And then everything, provided we do that everything correctly, should match up like that. Of course, I don't have any support holding it, so it doesn't want to fall out, but trust me, it works. So there you go. You have got yourself a structure. This will probably take you about a day and a half. Well, it took me a day and a half, so if you're a bit more efficient with your sewing, it might, and if you're a bit brighter than me, it might take you quicker. But you have your structure, and right now, what you do is you measure. You measure everything. Okay. First thing you measure your outside dimensions. So don't forget these bricks count. Okay. So you count from your outside bricks to the very front of the outside, and as you can see, it's 56 in my case. So you note that down. Then you measure this dimension over here, and you won't be able to see it, so you have to trust me, it is 36. You note that down. You measure your height, which is, in my case, 26.5. You write that down. You measure the inside of your chamber, which you also write down. Okay, and then you start up Excel or sheet of paper, regardless, it depends on what you prefer, and you will need to figure out how much sheet metal and how much angle you're actually going to need. The angle that I've used, this is a cutoff obviously, is this. It's a 25 mil by 25 mil by, yeah, it is 1.5 indeed, yeah. Okay, I used about 6.5 meters of this stuff. Another thing you're going to be using, and now, there we go, is of course this. You've seen this in the previous video. It is sheet aluminium, and this is, I think, 1.2, if I'm correct, millimeters thick. Sorry, it's 1 millimeter thick. There we go. It's 1 millimeter thick. It's perfectly fine. Okay, to give you an example, a taster of how big it has to be, I've used a sheet which was 1 meter by 1.5 meters. So it's 1.5 square meters of sheet aluminium. Not the cheapest thing in the world, I must admit. It was cheaper than steel, simply because of shipping issues, because of shipping cost. But, well, it works perfectly fine, and it's lightweight, and it doesn't rust. So, good enough for me, I think. Okay, so once these arrive, or once you've actually went somewhere to pick them up, you need to figure out the most efficient way to actually lay everything out. I'm talking about the steel or aluminium that you're going to be using. Quite simply because you don't want to end up with a lot of waste. And what I did is I actually loaded up into some engineering program, SolidWorks to be precise, and I made several rectangles of the dimensions I will be needing for the sides and top and the bottom and the door. Don't forget the door, okay? And the back, of course. And I simply moved them around until I found how they can interlace and match into the smallest area of a rectangle as possible. I mean, people who are bright pretty much can probably figure this out right away, but I'm not very bright, so I can't. Another thing is, don't forget, you need an extra piece for the front of the oven as well. Don't forget that, okay? It's gonna have a big hole cut into the middle of it, but it still needs to be there to keep all the bricks from falling out. So, I mean, that's very easy to miss. You can see a gap through the middle there. There we go, you can actually see a light gap, but don't worry, this all closes up, it's just wonk at the moment. Okay, so make sure you do that, and after I was finished cutting everything, okay, let's walk outside. This is how much of that sheet aluminium I got left. Not a lot at all, is it? Okay, we'll be using that up for something else. Let's get back into the workshop. So, we've talked in detail, I think, about the about the actual brickwork. So now you should be able to figure out how to put everything together. The next thing we'll be talking about is, and we have a mosquito there. Go away. The next thing we'll be talking about is the framework. So what I'm gonna do, I will put this away, and I'll bring the frame in here, and I'll see you in a minute. Right, welcome back, guys. It was rather simple, really. All you need to be doing with this is you need to be after you've worked out how big everything is. One important thing is over measure by a certain amount. How much is up to you. I think I will measure it by a good 2-3 centimeters on every direction. Now I knew I want the height to be higher than what my brickwork was, simply because I wanted to put vermiculite on the top for extra insulation. So consider that. Another thing to consider is why you want to over measure is well, first of all, so everything fits. And if you've got a tiny gap across the sides over there, you can always fill it up with vermiculite. It's very cheap. Okay, it's cheaper than bricks, and it's much easier to use because you can just pour it in. So make sure you over measure by a certain amount. Okay, you don't want everything to be skin tight. You'll take care of it later, but don't go over the top either. Okay. So all you need to be doing is take a good Sharpie or marker pen or something else, or a good pencil that can write in sheet aluminium, and draw your shapes out on the sheet that you received, and cut them out. So it's up to you what you use to cut them out with. I used a power hacksaw with a metal cutting blade in it. Yes, it does mean that sometimes the cuts are a little bit wayway. Let's use that word. Okay, but that's because I'm really rubbish with my power hacksaw. If you're good at it, you'll be able to do it quite easily. You can use an angle grinder. I've used that on several occasions. For example, to cut out the front, I've used an angle grinder. Some people say you shouldn't use an angle grinder for aluminium, but this is only 1 mil thick, so who cares, really? With a proper thin cut-off bit, cut-off disc, you should be able to perfectly fine. Another thing is, after you've cut all your pieces out, you will be cutting the corner braces out from that corner that you hopefully have received together with your sheet. Couple of things to consider. First thing is, you want pretty much all the corners to be angled at 45 degrees centigrade. At 45 degrees. Okay. The reason for it is so they can mesh with one another easily. Up to you how I do it. The final thing I decided to do is simply cut them all off square with an angle grinder, and afterwards take my adjustable square, okay, mark it out at 45 and cut the bits off with the angle grinder, and as such I ended up with lots of these tiny triangles. Okay, and I did all that with an angle grinder. It's not the most accurate way of doing it, but then again, you don't really have to be super accurate with something like this. Okay, fractions of a millimeter are really not critical around here. Even if you do end up with a little bit of a gap, quite frankly, who cares? Okay, so there we go. So after you cut all of those, you will want to be drilling a lot of holes, a lot of them, and you'll be using rivets and a rivet gun. And I can't say this enough: if you get a good rivet gun, okay, because mine is absolute rubbish, and it was a pain in the crack to use. The way you drill holes in an angle, at least the way I did it, and I think it's the best way of doing it, is go, if you have a pillar drill, and you know you should have one, everyone should have one because they're incredibly useful. Have a pillar drill, set up some sort of a backstop on it, so you know you don't wander around, and just drill a hole of a lot of holes down there. It's as simple as it gets, really. Okay, the spacing is not overly critical, because once it comes down to it, if you feel that it needs some extra holes in there, you can just always drill them with your handheld drill. It's no big deal. Okay, but just a good guesstimate is, let's have a look, what did I use over there? 5 centimeters, okay? A hole every 5 centimeters is fine. 2 inches, for those of you who speak Imperial. That should do perfectly fine. After you've done this, what you'll want to be doing is taking whatever it is that you decided to start with. I believe I've started in one of these corners over there. I think it was this one. This is where I started and I worked out around it. Take one piece of sheet aluminium, drill a hole with, well, ideally what you'll be using is something like this. So you just drill your holes and put some pop rivets in. If you want to be able to take it apart, let's use that, you can screw everything together with these self-drilling, self-tapping screws. It's a more expensive way of doing it, probably could be a bit more of a easier way to do it, because it drills a hole for itself. Okay, the problem with it leaves a very long tail once you have it in there. I mean, these are one of the shortest screws that I actually could find, effectively, and that still had the thread depth enough to join 2 pieces of steel material. But it will leave this very long and nasty drill bit end on the inside, and that will interfere when you start putting your bricks inside. Okay, you'll start to drill into the bricks if you want to do everything nice and flush. The rivets, on the other hand, they leave a very short and, more importantly, blunt tail behind them, so you don't risk damaging or cracking. That's the worst thing that can happen of the bricks that you're going to be putting inside of this. So my advice is use rivets to put this together. Okay, they're very strong, they're very cheap, they're very light, and nothing wrong with you using that, really. Okay, so once you've done your 4 sides and the bottom, you want to be doing the top. Okay, and the top will always serve as the cover for everything, like a hood on a car. And much like a hood on a car, or a bonnet, if you're British, on a car, you want to be able to remove it. You want to be able to open it. Ergo, you don't want to rivet it on, because otherwise it's going to be a pain in the ass, won't it? So what you do is you take your lid that you've constructed, you've cut it out, you put angles on it. It's perfectly fine to rivet the top. The only reason I put 2 self-drilling screws in there is because I ran out of rivets, believe it or not. Okay, and put it on there. There we go. Okay, and now this is where the self-drilling screws come in handy. Is you can simply screw
this whole lid. I showed you this in the previous video, didn't I? You can just screw this whole lid on across the top. It drills its own hole, so you don't need to worry about drilling through the sheet metal, and it makes life nice and simple. There we are. Okay, so this is your frame. Now, one thing I did forget to mention, and I hope you're still watching, I did forget to mention when I was talking about the bricks, is the door. Don't forget that you need to leave bricks to do the door. Okay, and let me just show you how my bricks are going to be arranged in order to accommodate for that. Okay. There we are. Okay, they're going to be just like that. Now, I will have a bit of an issue, and I will try. I should be able to solve it. No problem. Is hinges and the closing mechanism. Okay, so these are the hinges I'll be using, and what you'll find is they are the lift-off type. So you can remove the door very easily if you need to. You need to decide for yourself this time how many bricks you're actually going to be using for your door. I've decided to use 4. Put them on their narrowest end so that as much material is in the way effectively as possible. You can put them like this. Up to you. Okay? You will use less bricks. At the same time, you're gonna have a lighter door, which is an advantage, I suppose. But you will be losing more heat through it. So it's up to you. Decide beforehand, and then buy your materials and cut out your sheet metal and cut out your angle accordingly in how you want this to actually look and how you want it to be. Personally, my bricks, like I said, they will be rendered in this way to make sure it is sealed. Let's put it that way. Okay. I haven't built the door yet, so as soon as I actually get to doing it, I won't now because I can hear it's just started raining, so I can't work outside. I'll be doing that for you, and I'll be trying at least to guide you through it, how to actually do this. I imagine it's going to be a pain to be able to fit the door in here. So, as for the brickwork and the framework, I think that's pretty much it. It's not rocket science. Why do I have a suspicion it's going to be a very long video about me talking about pretty much nothing? It doesn't take a lot of skill. It really doesn't. It's very easy to do. Just takes a bit of time, and it's rather simple. Okay, in the other parts, I think I promised to talk about maths, which I hate, but whatever. We'll be talking about maths. We'll be talking about how powerful your kiln has to be and can be. Okay, there's a limit. And we'll be simply talking about what parts you need to order. Hopefully, by the time I'm shooting the next video, all the parts I've bought online would have arrived, and I'll be able to, well, show you what I'll be doing, how I will be doing it, and why. Certain things may not be very obvious, for example, the various relays and micro switches, but I'll be able to explain to you why I'm actually doing it the way I'm doing it, okay, and hopefully you'll get a bit of a better idea. Okay, by the way, no, if you're not a knife maker and you don't care for knives or anything, well, don't think that this series is not for you, because kilns like these, albeit maybe smaller, are very useful for people who are like model engineers. You need a lot of you need a way to actually heat treat whatever it is you've just turned on a lathe or milled on a milling machine or anything else, or something else for whatever reason it might be. As well as tool makers. You know, you need to heat treat your tools as well, don't you? And you know, you can either do it in a coal-fired forge or a gas forge or a blowtorch or whatever. You can use a proper high-quality tool. And well, my point is, what I'm trying to make is, it's not just the knife makers that will be benefiting from this. But other than that, that's pretty much it for this video, and I'll see you in the next episode, I suppose. Have a good day, and take care.